This is the second of 4 videos that I've made for solving trigonometric equations. If you haven't watched the first one, I'd recommend you do that so that you can have the 5 steps that I'll be using in mind as we go through the problem. First thing that you always want to do when you're solving a trigonometric equation is to isolate the trig function. So in this particular case, we have 4 cosine square of, I'll just say the argument, minus 3 is equal to 0. I'm going to do this in 2 steps. First thing I'll do is isolate cosine squared, and to do that I will add 3 and then divide by 4 on both sides. So I'll get 3/4. From here I can take the square root of both sides. This will give me cosine of theta plus pi over 6 is equal to, I'll get the square root of 3 over the square root of 4, which is 2. And because I took the square root of both sides, I have to remember that I could have both positive and negative roots, so I include the plus or minus. Now that I've isolated the trig function, my next step is to figure out what angles on the unit circle correspond to this argument. So I'm looking for values for theta for theta plus pi over 6. So the cosine of any angle is my x-coordinate on the unit circle. So I want to look at where x is either plus or minus root 3 over 2. Positive root 3 over 2 is probably right about here, and that corresponds to 2 angles. This guy up here is 5 pi over 6, and this guy down here would be 11 pi over 6. If I consider the negative square root of 3 over 2, that's right about here for my x value. And that gives me 2 more angles of 5 pi over 6 and 7 pi over 6. So on the unit circle between 0 and 2 pi, I actually get 4 different angles: pi over 6, 5 pi over 6, 7 pi over 6, and 11 pi over 6. And normally, I would write all 4 of these, and then I would add 1 period, or I should say k times a period to each of them. But when I look at this, I notice that there's some symmetry. In particular, if I go between this angle up here and this one down here, I can always get from one to the other by adding pi from here to here, adding pi again and again and again. So these 2 solutions could be combined by starting at pi over 6 and adding any number of pi's, so plus pi k. Likewise, these 2 guys, 5 pi over 6 and 11 pi over 6, they differ by 1 pi as well, going forward or back. So I would say this is equal to this, or I could start at 5 pi over 6 plus any number of half revolutions pi. So now that I've solved for my argument, the next thing that I want to do is actually solve for the variable, or theta in this case. So as I'm doing that, one of the things to keep in mind is that theta and k in these formulas act as variables. Pi over 6, pi over 6, and 5 pi over 6, those are all constants. So when I isolate theta, I'm going to subtract pi over 6. I'm going to look for like terms. I'll subtract it from here. Pi over 6 minus pi over 6 is 0, plus pi k. Don't need the plus. Gotta find my eraser. And finally at the bottom here, 5 pi over 6, take away pi over 6 is 4 pi over 6, or 2 pi over 3. Again, plus pi k. So at this point I have a formula for my variable theta. There's 2 of them that represent a good stack of angles.